Let's carry on with circuits, okay? This is session 565. What we're going to do is we're going to carry on with circuits. This is question 13C that we're going to do. Remember what I said is we're going to input over here. We're going to put in, now we're going to put in a slightly more complex problem, but we're going to check the recipe is the same. So first of all, I had over here, I had a battery and I put in 3, okay. Coming down here, I put in an ammeter. Over here, I put in R1, and I had a voltmeter over here, and they could have said it's V1 and it reads 16 volts. Okay, and comes down over here now and splits over there. Okay, and we put in 4 ohms, another one over here of 12 ohms. All right, and they put an ammeter over there and an ammeter over there as well. And let's carry on going up over here. I put in another resistance of R2 and V, okay, like so. Just put this in to format like that. And then the last piece is we're going to join this up like so. And over here we say V equals 48 volts, like that. And there is our circuit. Okay, what did we say for question C? I'm just going to turn to my piece at the back here. Right. Okay, let's just have a look here. Okay, we start off by putting in the current. That's the first thing we do, correct? So I'm just going to keep to the same that I've done before and put in I going through here, I going there. Over here, we had I. Let's split it to I1. I'm just making sure that I've got it split the same way. This is back to I, and I goes through over there. And what did we say? We said, right. And they told us over here, they said that we had, I didn't put it in, we had a reading over here. We had a V over there equal to 8 volts. A reading there of 8 volts, right? So what does that mean? Okay. Well, first of all, let's work out what the effective resistance is over here, shall we? Because we've got 2 known resistors. So let's work out R effective there. How do we do that? Well, step 1, I'm just going to go back to black. We say 1 over R effective is equal to, because they're in parallel, so it's equal to 1 over 4 plus 1 over 12. When we put 12 over there, goes in there 3 plus 1 is equal to 4 over 12. And then the R effective is going to be, flip it up, is going to be 3 ohms. And we can go back and put in that now. So effectively, we can say that I have got rid of those 2 and replaced it with a 3. Now you can see the value of it, because what is going through there is I. So now I can work out I straight away, can't we? We can say, let me just go. Remember we said V is equal to IR. They've given us V of 8 is equal to I times 3. Okay? Correct? So therefore, we can say that essentially we've got 8 over 3. All right? So we can work out what our I is. Let's just have a look over here also. Before we even get there, we could have said to ourselves, hang on, just look. We have got a V of 8. Look over here. We've got, just put a dotted line around here for you. We've got R and V, so we can work out I1 straight away. We can say I1, okay, from V equals IR, all right, we can say that I is equal to V over R. So I1 is going to be 8 over 4, which is going to be 2 amps. All right? And what is V2? What is V2? V2 is this one over here. And you know that V2 must be equal to 8 volts as well. Why must V2 be 8 volts? Because the voltage across the parallel pair must be the same. You can't have a different voltage because it is a current splitter. Remember, current splitter, voltage stays the same. Voltage splitter, current stays the same. That's what you got to remember. Best is through the little diagram, right? Voltage splitter, current stays the same, voltages change. Current splitter, current changes, voltage stays the same. So therefore we've got that. Now we can go to this piece, the next one, and we can say, okay, hold on. Whoop, let's just look here. We'll get back to the other guy. We can now say that I2, okay, V2 is that, and R is equal to 12. Therefore, we can say that I2 is going to be V8 over 12, all right? And 8 over 12 is 2/3, all right? So now I can immediately go back onto my diagram and say I1 over here was 2 amps and I2 is 2/3 of an amp. So my current I is going to be equal to what? 1 and 2/3, which is 8 over 3 amps or 2.67 amps. Correct? Let's just go back to the green one. Okay, I'm going to erase it and start it again. Instead of doing that, let's just see what would happen if we carried on. We say, right, now I say I is equal to V over R, right? V is 8, R is 3, therefore it equals to 2.67. Could have got it straight away from that, right? You can use your ghost, I call it ghost resistor. You can use it, okay? The current that's going through it is a very important little trick to finding it, okay? It's a bit of a time saver in some cases to be able to use it, especially if you've got 3 or more, okay? It's quite a cool trick to use. So we now know what the current, so we know what it goes through there is, okay? Right, so let's have a look here. And the next part is we say, right, 2.67, what do? We say, right, you just read I equals 2.67 amps, and over here, I equals 2.67 amps, okay? So then we put that on the drawing, okay? What do we do next, okay? We say, okay, in the next one, we say, okay, moving to R1, we've got 2 out of the 3, all right? So let's have a look, okay, at R1, okay? Now we're going to R1 over here, okay? Let's see, we're going to look at R1. We know V of 16 and I of 2.67. Right? Can you see, this is like wash, rinse, repeat, isn't it? So we can say to ourselves, right, V equals IR, okay? This is at R1, the unknown R1. V equals IR. So what do we say straight away? We say, therefore, V, and they told us it is 16 is equal to I, which was 8 over 3. Let me just put that as 8 over 3. Okay, which is what I had here. 8 over 3 multiplied by R. Therefore, R1 is going to be equal to, and you can work it out, R1 is equal to 16 times 3 over 8, which is 6 ohms. Now we go back to our diagram and we put it on there. Equals 6 ohms. Solved. Okay, what's the next one? Next one, we say, okay, I think that was the R2 was 9 ohms, wasn't it? Let me just have a look here. Okay, R2, okay. And let's have a look here. R2, okay. Okay, right. Okay, and I did Yep, 48 volts is what we've got. All right. Remember we said the battery was 48 volts. Now, let me just stop here and let's go. Look at this. We've got 48 volts. We've got 16 there, 8 here. So can we work out V over there? Remember, the sum of the voltages across all the components must be equal to the voltage you use. So therefore, the V there is going to be 48 minus 16 minus 8, isn't it? So the V is going to be equal to 24, which is 48 minus 16 minus 8, okay, leaving us. So this must be 24. 24 plus 8 plus 16 is 48. No, you don't add that 8 twice of the parallels, okay? It's the same voltage across both. You're only going to use it once. So therefore, I know it's 24 volts. So if I've got 24 volts over there, I can then say that looking at R2, V is 24, I is 2.6, calculate R, and therefore I say, all right, let's go back and say, therefore, at R2, V must be equal to, we said 24 volts, and I is 2.67. That's a 2.6, guys. 2.67. Therefore, R is going to be equal to, R is essentially going to be equal to 24 over 2.67. Let's have a look. 24. 24 divide 2.67 is going to be equal to 8.98. Let's call it 9 ohms. Okay, 8.9887. I think we can safely say that that's 9. Okay, I should have said 2.666. Okay, if I'd have done it 8 over 3. Right, I got 9. Okay, so that's that one. Now, let's have a look at question D, shall we? All right, question D, all right, is a slightly different one. All right, I'm going to have to put in another page, which is cool. Okay, let's have a look. Given the following circuits, let's see. We've got over here, oops, let's anchor this down, okay, by doing that. Okay, and we've got a battery. I do apologize. I always go this way round, okay? In the books, a lot of the ones are reversed. I, for some reason, didn't reverse them, but please note that it could have been written like this as well, right? All they're telling us there's a number of cells in there. And they tell us this is a 12-volt source. And this comes down over here to a 20, whoops, over here, right? And we've got an ammeter here and an ammeter here, all right? And we've got another ammeter over here. Right? Then they say that we've got a point Y and a point X over there, and we have got a switch S1 and point B over there and point A over here. Okay, and that's like that. Okay, 20, I'm just going to fill in here, 20 over here and 5 over here, like so. All right, now, given the following circuit, they say switch S1 is open. What is the reading on ammeter A1, right? Well, if the switch is open, let's put the current in, shall we? Right, red. This is I1. This is I1 and I2. I just want to check that I'm using I1s and I2s the same way as I did in my I1 and I2. Yes, I did. And I is going to come up here. What's going to happen at the switch here? The switch is up. What happens to the electrons? They can't pass, which means there's a break. That means current can't flow. It's like water. It gets to there, it can't go further. That's the end. It just basically just sits there. Well, in this case. So what do we say? We say there's not going to be a reading on the ammeter. It's going to be 0. All right. What is the reading on a voltmeter placed across points A and B? So in other words, let me just go over here. They tell us that we put a voltmeter there. All right. The switch is still open. What does the voltmeter read? Okay. Now, a lot of people would say 0 straight off. The reality is that what is this side here? This side over here has got all of our negative charges, right? The electrons are sitting there. This side has got all the positives, so all the protons are sitting there. The voltage across there is equal to 12 volts. So we would say, okay, for question A, we would say the ammeter reads 0 amps. Question B, the voltmeter reads 12 volts. It reads the same as the battery, doesn't it? Because our electrons are sitting across there. They're not flowing, there's no current, but there's a potential difference. One side is plus, one side is minus, okay? So there's a potential difference for current to flow. Right, let's have a look at the next question then, question C. All right, you've got yours to get. Switch S1 is closed. Calculate the readings A1, A2, A3, V1, and V2. All right, let me put in my V1 and V2s. Okay, they've said V1 and V2 is across here. Okay, just put it in, make it look decent. So we've got voltmeters across there. Hold on, you should already know that V1 and V2, the voltmeter readings are going to be the same. Parallel pair, right? Never mind whether we've got a resistor over there. All right, so let's see. Let's calculate using this circuit. Okay, first of all, what do I have to do? The first thing I have to do is I have to calculate my ghost resistor. So I say, right, I put you in here. Here you go. Right? How much are you? I say straight away, 1 over R effective for my ghost resistor is equal to, see, 1 over 20 plus 1 over 5, and I've done it, so I'm going to get 5 over 20, which is 1 over 4. Remember, where's the error here? Most people forget to flip it. Therefore, R effective is equal to 4 ohms, so we can go and put 4 ohms in over there. All right? Now, we say, okay, that's that. All right? So what can we say now? All right? We know that V equals IR, because what have we done? We've reduced it back down to, I know I'm repeating myself, but sometimes it works. We've done 12 volts, and now we've got this, haven't we? We are down to a simple circuit of 4 ohms and an unknown I. So we can now say that therefore V is equal to IR. V is 12 is equal to I, we don't know, times 4. Therefore I is going to be equal to 3 amps. And we do what? We go back and we put it equal to 12 over 4 is 3 amps. So we go and we put it in, right? We say, there we go, 3 amps, and we go and put our 3 amps back into the circuit, all right? Let me just put it in red here, okay? So I would go and I'd put my 3 there, or, oops, sorry, no, I can't put it there, my bad, okay? I put my 3 amps over here, right? So this one is going to read 3 amps, but how do I now work out what V1 and V2, right? What do they read, right? Well, V1 and V2 must read the same, correct? Let's just have a look here, right? V1 and V2 must be equal to 12 volts because they must equal the total voltage in this. The voltage across the parallel pair must be equal to the voltage of the battery. There's no other resistors in the circuit, right? So therefore, I know what those V's are. So can we calculate what I1 and I2 are? Yes, we can. We say just move this up slightly, right, when it wants to. Let's have a look and say, well, let's have a look. V equals I1R. So V is going to be equal to 12, is going to be 20 I1. So R is going to be, sorry, silly me, I1 is going to be equal to, I1 is going to be equal to 12 over 20. Is it not? It's going to be 12 over 20. And if I work that out, that comes to be 0.6 amps. Now, you don't have to calculate the other one. You can go straight away and say it's 2.4, but let's just calculate it next to it. V is going to be I2R, so I can say 12 is going to be equal to, R is 5I2, so I2 is going to be equal to 12 over 5, 2.4 amps. Sum them and I get 3 amps, which is what it should be, correct? Therefore, we've now solved that, all right? Now, the last part of this is where they say, okay, we're going to now put, okay, we've got V1, V2, they must be the same, correct? They must be the same voltage. We've got A1, A2, and we've got A3 as well, all right? The total current in the circuit. Okay, now they say, with S1 closed, we add an unknown resistor, RXY. Okie dokes. RXY is now added over here. Okay? We don't know what it is. Okay? And we say we want the current to be 1.5 amps. Calculate the magnitude of RXY. What are we saying? Okay? We want the current to be 1.5. Right? It's currently 3. We now want the current to be 1.5. So what do we say? We want to limit the current. Okay, so we want to have a current flowing in the circuit of 1.5. What do? We then go back to our primal circuit, okay? Primordial, primeval, whatever you like, circuit. We say, hang on, there's still a battery of 12 volts here, okay? Current I, we want it to be 1.5, and R, right? So R total, can you see we don't know? But we know current, therefore we say, okay, therefore V equals IR, 12 is going to be equal to 1.5 times R, okay? I worked that out, so therefore R comes out to be 8 ohms, okay? You guys see what I'm doing here? We've got an unknown resistor, it's changing the current. It does not change the voltage of the battery. That's what's sticking on it. That's what it's given. 12 volts. Next year we do internal resistance, but that's a different story. But if it says 12 volts, it's 12 volts, okay, for our purposes. It's delivering a constant voltage. So that stays. The current is going to change because resistance is changing. So I go back to my circuit and I say, right, what am I doing? I am putting in, let me just spend a few seconds here. Remember we said we had our 12 volts? Sorry. Okay. 12 volts. And we had these two here, didn't we? Over there and over there. Now we're adding in another one, which we don't know. But what are we saying? We're saying that this is 1.5 and that's 1.5, right? We also know that V across here and V1, let's say, and V across this guy, V2, V1 plus V2 must be equal to 12 volts, correct? Because the sum of the voltages, V1 across this guy and V2 across these, they must be equal to 12, right? So if we take the whole circuit back, and that's the trick, what we're saying here is we're saying, look at this. We're taking it back and we're saying, right, okay, I can take the whole thing and I can work out what my new, that is R, sorry, not R effective, it's R total. It's R total, okay? It's R total, right? So now we know that this entire circuit resistance, let's make another page, the entire circuit resistance, okay, R total is equal to 8. Now that means, let's just look at the circuit again. There we go. Okay. Okay. This one here, RXY, these over here are still going to be 20 and 5. And if you remember, okay, on our drawing, we've still got this guy. I've just cut it out. Still got him, and he was how much? He was, I think, 4. Now, what are we saying? We're saying here then that the resistance of the total circuit must be 8. What is the resistance? Resistance total is going to be 4 ohms, this one, plus RXY. But 8 must be equal to 4 ohms plus RXY. Therefore, RXY must be equal to 4 ohms. So if we go and we put a 4 ohm resistor there, we will throttle the current back to 1.5 amps. All right? That is what we are doing with that one. Okay? Okay. There, basically, what we've done there is we have solved probably one of the toughest ones you're going to get at this point. Right? So with circuits, what do? We first of all, on our drawing, we put in all the known information. Put in your direction of the current I across each component. In other words, each resistor, because that's all we do. So what do? We put in the current. Okay. Then look where we've got 2 out of the 3 given, or look and see if we've got the total resistance given. If we've got the total resistance given, then we can go ahead, work out the total circuit resistance, okay, and then work out the current. If you're given the current, you can go and work out the circuit resistance. You can always work out the third one from the other 2. Okay? Please practice some circuits. They're not as difficult as you think. Just follow the recipe for them and enjoy it, because it's very, very rewarding when you get it out. Oh, and by the way, you are going to get some currents coming out as like I did 8/3, 2.6, 1.67 and things like that. They're not always necessarily going to come out as exact numbers. Just before we end this off, remember also those 3 equations. The V equals W over Q. Q equals I delta. They may tell you that in this resistor so many joules is given off, all right? So much energy is dissipated, okay? They can tell you that. In that case, you might have to use one of those formulas. That would be quite an advanced question, quite a cool one, but always remember that you could use those as well. That's why it's grouped under electricity. Okay, cheers. The next one we're going to do is we're going to start mechanics, which is everybody really just goes, I don't like this, but let's find the recipes for it and solve it. Cheers. Till then, bye.